Okay, Leetcode 125 is an easy question. We just have to check whether a string is a palindrome or not. So basically, if, for example, if this A, B, A, this string is a palindrome. Palindrome being, if we reverse the string, we'll get the same string. Right? That's it. That's a palindrome. So for this question, there are two rules. There are two small rules which will not make this thing hard, but a little tricky. The first being, don't consider non-alphanumeric characters. For example, they could give us a string race a car. So this is the string that they can give. In this case, this is actually a palindrome because if we check, if we will go line by line from, what we'll do is we'll go from the beginning and from the ending. So we'll take one by one. We'll look at R. Yeah, it's palindrome. It's A, yes. C, it's E. So basically, let's look at this thing. Let's look at this string. It's actually a palindrome. R, A, C. We don't consider this space gaps, which means if it was like this, even if it was like this, these space empty characters will not be considered at all. We'll jump directly to A. Both are same. So if we have anything like percentile or slash or anything like that, these won't be considered at all. We only have to consider the alphanumeric characters in the string. That's the first rule. Second rule is uppercase can be equivalent to lowercase. So if it is capital R and if this is capital C, still this and this are the same thing. Basically what we can do is we can consider that capital R is also equal to small r and capital C is also equal to small c. That's basically what they're saying. So rule 1 is we can only don't consider non-alphanumeric characters, and rule 2 is uppercase is equal to lowercase. So using this we have to find whether a string is a palindrome or not. So basically we have two approaches for solving this question. The first one, as you know, is for much more competitive programming sense, which means it is good for execution, for fast execution, but when it comes to interviews it's not that necessary. So we'll look at both of them. The first one being, look at the first one, the first approach. So the first one is simply what we do is, first, since we shouldn't consider any other characters which is non-alphanumeric, what we are going to do is, if we are given a string race car, some percentile, something like that, this is a string. What we'll do is we'll systematically go through the string, each and every individual strings, and we'll see which one is alphanumeric and which one is not. We'll update that thing. So what I'll do is we'll use a for loop for each and every occurrence. We'll check whether it's alphanumeric or not. Let's take this as capital R. So yes, this is an alphanumeric character. A, yes. C, no, this is not one. So A space is also not one. So C, A, R. This is the final thing. We went from this to this. The second what we'll do is we'll convert the string to lowercase. So what we'll get is R, A, C, A, C, A, R. So now what we will do is basically check what we return is, since if this is the let's take it as S3, this is S2, this is S. So what will return is S3 is equals to S3 of inverse. So what we're doing by here is, since if a string is a palindrome, then the reverse will also be equal to the inverse of a string will be equal to the string itself. So S3 should be equal to S3 of inverse. If that is not the case, then the string is not a palindrome. If that is the case, then the string is a palindrome. This is basically the thing we can use for checking whether a string is a palindrome or not. So for this, from this to this, what we'll do is we can check for each and every iteration whether, for example, if this I, for each iteration of I, if I dot is al alpha and mu, what the function we'll use for this is I dot is all num. So it will return whether the particular occurrence is an alphanumeric character or not. For this one, what we'll do is simply s2 dot lower. That's it. So s2 is equal to s3 is equal to s2 dot lower. We'll get s3, and using this we can successfully execute the code. But we shouldn't use this thing for interviews. It's only for competitive programming. For the interviews, I'll tell you the other explanation. So for approach 2, for the interviews one, the one which will actually have an approach is, let's take the same thing, RACE percentile slash what do you take, percentile again, CAR, we'll take capital R. Okay, so now what we'll do is we can use 2 pointers for this one. That is the actual concept of this question, is to use 2 pointers. This is a 2 pointers question. So we'll use these 2 pointers. What we can do here is we'll go through each and every iteration and we'll check whether the value that took are similar or not, which means whether R is equal to R or not. So what I'll do basically here is, the first thing is I will move forward. It will go here, it will move in this direction, and J will move in the other direction. J will go here like this. So all of this is to come to the middle where I is equal to J. We'll use a while loop to iterate I and J till I is equals to J, and in the meanwhile, if I till I in the now if I is equals to J, if the condition is met, which means that till the condition was met, I is equals to J, there is every single integer, every single occurrence of I and J were equal. If that was the case, the string is a palindrome. Now let me tell you what I mean. Basically what we'll do here is, let's check R and R. Yes, we'll just check whether R is equal to R. Now since since rule 2 says that uppercase is also equal to lowercase, so R is equals to R. Now we'll go to the next iteration. This will be this, A and A are equal, next C and C are equal, next. Now this here, what happens is, when a non-alphanumeric character has been what happens here is, when a non-alphanumeric character is encountered, we'll use a while loop where it will iterate till an alphanumeric character has been approached. So now it will go till here where till I is this. Similarly for J, it will go till this is J. And since I is equals to J, yes, now I is equal to J, and A is also equal to A. So since that is the case, we'll return true. But what if that wasn't the case? If it was E, what will happen here is, let's take a percentile again. So here's a pointer, R and R are equal. Now when it comes here, it will go here. It's like an iterate here. It will check C is not equal to A. So when this happens, it will automatically return the value, the answer as false, and we'll get the answer. So what we're basically doing here is, we're checking if each and every particular character from the first, beginning and the ending are equal, and will come closer and closer. The pointers I and J will come closer and closer till the meet, and in between, if any of I is not equal to J, it means that the character itself is not a palindrome, so it will return false. And if I is equal to J, the condition has been met. That means none of the alphanumeric characters from I and J were not equal. So which means that the string is a palindrome. That's the basic concept. So the approach here is basically first thing is what we do is simple two-pointer approach. That's it. So this is a simple approach. Now I will write the code down. Okay. So let's look at this code now. We'll go line by line. We initialize 2 pointers I comma j. I being the start of the string and j being at the end of it. Now, while I is less than j, as I told you, as long as they meet, we keep checking this condition. We'll go through this while loop. So now, first, we need to first make sure that it's alphanumeric. First we need to make sure that the particular pointer, the character in which I and j points, is an alphanumeric character. So if it is not an alphanumeric character, we'll keep adding or we'll keep decreasing the value of j while not of s of I dot alphanumeric and I is less than j, I plus y equal to 1, which means as long as it's not an alphanumeric character, we'll keep incrementing the value of I, and we'll also make sure that I does not cross j. That is the point. We should also make sure that I shouldn't cross j at any point. I plus 1. Similarly, this thing is the same thing. It's for j, that's it. If not, while j. So what happens with these two is we'll confirm that the I and j, the character that I and j points, is an alphanumeric character. The rest of them aren't. These are not relevant. So this is the main thing. This is the thing where we check if s of I dot lower, maybe if it's capital A and this is small a, s of I dot lower, since it's lower, so we're converting these two into lowercase characters. If s of I dot lower is not equal to s of j dot lower, we return false, which means that if it's b, we convert it to b is not equal to a, so we'll return false. So what happens is, with this condition, we'll go through each and every iteration, and if in any particular iteration this character pointing I is not equal to the character pointing j, will return false since it's not a palindrome. And we'll increment I and decrement j, and if the condition satisfies, which means that I is equals to j at one point, we'll get out of this loop, which means that we have checked the entire string and we have seen that each and every character of I matches the character of j, which means we return true since it's the palindrome. So basically this is the intuition for the code, and this is the code itself. If you write this thing, if not for here, if you write this condition again, if condition again for s of j, this is the entire code that we're supposed to write. We'll also upload this on GitHub, but you try to write this thing on your own. So yeah, thank you.